I've documented in previous videos that my Elise has a buzz coming from the transmission, and it vibrates at some kind of frequency that excites the shifter, so you get a buzz out of the shifter. So I've been working to resolve that, and the thing that I have done in the most recent past is put padding, rubber padding between, this would be the engine block, and this is the bracket that holds the shift cables. And the buzzing, just to be clear, is not in the cable that actually does the shifting. It's in the jacket of the cable, and this bracket attaches directly to the engine. So my theory is that there's a vibration that comes from either the engine or the transmission, and it's transferred into this bracket, which transfers it directly to the cable sheaths, which translates it back into the cabin at the transmission end. The reason I believe this is because I can disconnect the actual shifter cables, the rod ends, and rev the engine and still get the buzzing. So I believe it's coming from the jacket. So what I've done in the past is added padding, this would be the engine block, between the engine block and the bracket, and then it's just some thin rubber, and then between the bolts and the bracket I added some more rubber isolation, and then I screw them together like this. And it has knocked the vibration down. It was very buzzy at about 3,500 RPM, and you could hear it really well. And I can get it to reduce the buzziness, but it still exists, and it's still kind of annoying. It'd be nice to totally eliminate it. So this is the original design as Lotus designed it. So the bracket just mounts directly to the engine, and what I've got, just as an example, is a little bit of rubber between the bracket and the engine, and the bolt heads and the bracket, so you can allow some motion in here. Well, I still have the buzz, and I want to work to illuminate a little bit more. So what I've been playing with is the idea of a dedicated gasket and a floating, more designed-in floating design for the bracket itself. And so I've 3D printed a bunch of parts here, and I'll just go through a little description of what I'm thinking I'm going to try next. So I 3D printed a representation of the bracket. What I can do with that is just put bigger holes in it before I actually do any drilling. And now my thought here is that what I'm going to do is have some standoffs, and the standoffs are what will hard mount into the engine block, and then I'll have a plate that sits on this end, and so I'll screw this together to demonstrate. So when I screw these down tightly, now I have the engine. I have a plate that's very solidly mounted to the engine. So this is also going to be moving around, and then the bracket itself is allowed to move both forward and backward and up and down. So the holes in the bracket are enlarged. What I did is I opened these up from 10 millimeters to 16 millimeters, and these are 10 millimeter ID and 12 millimeter OD. So it's a 12 millimeter to 16 millimeter gap in there that allows some motion. My hope is that what I can do is put gasket between all of these locations and isolate this bracket from the engine block, and but still have enough rigidity that the shifter is pretty solid. So what I've done is designed some gaskets. So there's two sides of the gasket. This backside gasket, I don't know if this is going to show up in camera very well, but it has some fingers in the inner diameter. So the standoff, you can see the light behind it. There's a little bit of flexibility between the gasket and the standoff, and then these ribs have some pretty good flexibility in them as well. And what I'll do is I will mount this gasket to the back of the bracket. It's a little tight in this prototype, but I'll open up the holes a little bit. It'll be pretty easy to get in. So I have these standoffs. So now what I've got is I've got isolation, vibration isolation between the standoff and the bracket itself with those tiny little fingers on both of those. And then the two gaskets on either side of the bracket have ribbing. And so the ribbing hopefully will allow the vibration that will come through both the engine mount and that solid plate. It'll isolate those and not translate into the shift bracket. So now I come down with those, and then again I have this solid. This will be aluminum, but I modeled it in plastic, obviously. Now I can screw these screws down tight because they are mounted between the engine block and this bracket, and the shift abutment bracket floats, but it floats within this rubber. It's too bad it's all the same color, so I apologize for that. But this abutment bracket floats between the plate and the engine block, and it's rubber isolated everywhere. But it's ribbed and it's pretty stiff. So during a shift action, I think it'll be stiff enough that you don't get a lot of motion in the bracket relative to the engine, but hopefully all of the little vibrations from the engine don't make it into the bracket, or it's changed to the frequency to the point where it doesn't make it in the bracket. So I'll test that out and see if that works. These gaskets, I will use the printed gaskets. So what I did is I'm using a material called TPE, which is some mixture of urethane and natural rubber that can be 3D printed. So I designed these in CAD and then printed them up in my 3D printer. And these are the actual gaskets that I'll use. I also, just to test out different profiles, tested out built this gasket. And you can see it's got a lot less support on it, and these little extensions are actually little 45-degree pegs, and there's much less of them. So they don't support that abutment bracket as well, but they also probably wouldn't allow as much vibration through. And then this is the backside one with the little fingers in the holes. So that's a progress report. We'll give all of this stuff a try and report back on if it was successful.